Hello and welcome back to CES 2026. We've made our way over to the CES Foundry where we're looking into quantum. It's kind of the first year for quantum coming to CES, but I think this is really exciting because we get to see what's going on with quantum coming to actual applications. And I'm joined by Pouya, who's from QCI. You're the Chief Revenue Officer.
Correct.
Thanks for joining us here.
Thank you so much for stopping by here.
Yeah, well, I think it's really interesting what you're doing. You were kind of explaining to me this a little bit earlier, that you're really application focused. And I think what we're looking at is how is the technology actually meeting the consumer or end user in what they're doing today. So a big piece of this seems to be what you guys are focused on. Kind of talk to what QCI is about, how you go to market, and that way people get a better understanding.
Yes, at QCI we are focused on 3 C's, capture, compute, and communicate. The naming for quantum sensing, quantum computation, and quantum communication. These are the 3 things that we focus on. But what we have brought into CES is mainly focused on our quantum computation technology, which is based on photonics, which is the science of engineering rays of light. And the reason that we have selected photonics as our platform is that photons do not interact much with their environment around them, which means that they are much less prone to noise. And that gives us an engineering degree of freedom, which means that we can now design these systems operating at room temperature because of that degree of freedom that we have in terms of not interacting with the media. And we have made these, the hardware and the software for these quantum computers. Our flagship is Dirac 3. That can operate at room temperature. It has a very compact form factor. It's actually desktop. It's 4-rack unit. It is actually right now deployed in a data center as well. It has cloud access, and we have developed certain applications for it because we understand that we need to focus on the quantum in a sense of changing people's lives. Our vision is to bring quantum into the hands of people. And that has brought in for us to focus on the application. There are several applications that we showcase here live at CES. One focused on portfolio optimization for finance applications. One focused on drone logistics, on drone routing and finding the best route for a drone. Another one on quantum machine learning, using actually real credit card fraud, credit card transaction fraud data to use for training of the AI, and we show that we get advantage over the legacy ways of doing it, which is done with CPUs and GPUs and legacy algorithms. And we show much faster, up to 5 times faster processing and much larger processing of data at a fraction of power. Because one thing that everyone probably knows that these days is that AI is just consuming lots of power. If your energy bill has gone up, it's the default to the AI and data centers. So, and that's because that's very, very power intensive, and part of it is used on training, for instance. And actually from the operator's perspective, training doesn't generate them any revenue. They want to actually focus on the actual calculation.
It's more going to the inference and using the actual AI.
Yes.
And that's where you guys really come in, right? Is helping people use models and be able to do things like understanding proteins and other different cellular level type stuff, unwrapping DNA and things, but also, like you said, if there's no noise, you could see it in a manufacturing zone where you're not going to have that interference and things like that.
Exactly, and a key feature of our system right now, it's at Gen 0, and we have shown that it can be used for real life applications that bring business value to people, to the enterprise, and also to the life of people. Now, imagine what the next generations would look like. And we actually invest heavily on the interaction that we have with our clients and customers to get their feedback to incorporate them into our product development. You mentioned protein calculations. Actually, we do have a project working with a research institution in New York that works on the exact same project. And based on that interaction, we now know where the next product needs to go, how many qubits we need to make, how fast we need to get to the results, and all of that. And these are the key information that you really get by offering something to the market, even at the level that it is right now, and get that feedback from the customer. And people start feeling that it's real, seeing that it's real, and believing it. And that's our intention here at CES.
So talk a little bit about that, because I think what you were telling me earlier is that, again, it's a crawl, walk, run strategy with this. This is not like trying to build the Uber frozen back in the thing, general purpose quantum computer, it's really focused on these applications.
Yes.
Kind of help people understand what that
Yes,
means.
so our technology is very application specific. It's an analog photonic-based quantum computation, which that means that it can solve certain kind of problems, math problems or industrial math problems really well. It doesn't mean that it's going to solve every kind of problem like a gate-based or a universal quantum computer can do, but not everyone needs that universality. I mean, if I can imagine sometime in the future that you want to have like a better real-time routing of your GPS on your cell phone, and you need your quantum processing unit, your quantum computer, co-located with your CPU on your mobile device that you're carrying, and uniquely to our technology, we have a pathway to get there. Our system is a little bit bulky. It's on a rack mounted right now, but that's Gen 0. And based on the improvements that we get and that we can get into like integrated circuit format at some point in the future. There's a pathway to that. And for that purpose, we need very high performing optical components. And knowing that, we actually have built our own optical component manufacturing fab in Arizona. And that way we have full control over the element, the components that we make, and we know what we need, what target we need to hit, and we focus our energy all on that to be able to make the prototype, to go from the tricycle to the bicycle to the car to the flying car, and what America brings in the future. I mean, it's always nice to imagine a future that is very advanced, but we are now, and we are focused on now, and we are focused on the problems today, and we are trying to solve those first, and then go to the bicycle next step.
I love it, Pouya. Thank you for coming on board. I really appreciate it. Check them out. Again, I love this strategy because it's really focused on where the rubber meets the road,
Exactly.
or the manufacturing meets the line, and being able to be application focused.
100%.
Thanks again for coming
Thank you
on
so
board.
much.
Yes.
I appreciate it.
And thank you for watching this episode of theCUBE from CES 2026. We'll be back with more.